There are 4 different views in Segue: the network view, the Ego network view, the event type editor, and a table view. In this video, I'm going to explain the detailed functionality of these 4 different views using the Enron dataset. There are 142 employees in the Enron dataset. We focus on the email exchanges among these employees between March 2000 and February 2002. 2 employees are connected in a network snapshot in a month if there are email exchanges between them in that month. Hence, there are 142 Ego networks. Each has 24 snapshots. Each node has an attribute which can be one of CEO, President, Vice President, Director, Managing Director, and so on. The network view shows an overview of the entire network. Each node represents an employee. When users have not defined any event types, the nodes are put into clusters based on their attributes. Users can hover over the timeline to see the connections between the nodes in a particular month. The Ego Network view provides the detail of dynamic ego networks. You can click on a node in the network view. The Ego network with the node as a focal node is visualized as a timeline visualization. The table view is a data table showing all the Ego networks in our database. You can also click on a row to visualize the Ego network as a timeline visualization. The width of the timeline visualization encodes the size of the Ego network, that is the number of nodes in the Ego network other than the focal node. This visualization is constructed in several steps. We first draw some lines in each time step. The height of each line encodes the number of nodes with a particular attribute the focal node is connected to. We then connect the rectangles to have the same color in 2 consecutive time steps together. By hovering over the legend to filter out some of the lengths, we can see that John Lavorato connects very frequently with vice presidents, but he does not connect very frequently with directors. By hovering over a time step, users can inspect the Ego network snapshot in that time step in a network view. By clicking on the timeline visualization, users can store the Ego network snapshot in a network view to explore it in a greater depth. When a mouse cursor leaves the timeline visualization, the snapshot is still kept in the network view. The largest node is the focal node, and the other visible nodes are the nodes which are within the one-step neighborhood of the focal node. Users can click on the log to restore the network view. In Segue, each Ego network is represented as some time series. Users can select a time series type from the time series menu to inspect the time series of each Ego network. For example, you're now seeing the size time series of the 2 Ego networks. Each time series is normalized by the maximum value in the time series. Users can click on this button to see the unnormalized time series. The event type editor allows users to convert dynamic Ego networks into feature vectors to create different spatial layouts of dynamic Ego networks. Suppose I want to create a spatial layout in which the dynamic Ego networks with similar size are closer. To do so, I need to separate the dynamic Ego networks which maintain a small size from those which maintain a large size over time. With Segue, I can define 2 event types, size is large and size is small. To define size is large, I select the size time series type from the context menu. You can set its specification to be a range of values or a range of slopes. Let me define a range of values. The Ego network view will provide a preview of the events that will be extracted for the current size range. I know that this size time series has a value between 10 and 66 in these time steps. Let me rename this event type as size is large and click Add. An event type named size is large is created. Let me create a range between 0 and 2 and name it as size is small. An event type named size is small is created. Users can hover over these event types to see what are the events extracted for these two ego networks, which are of these event types. After adding an event type, the network view and the event column in the table view are updated. The event column in the table view shows the event sequence of each ego network as a pixel display. The x-axis in the event column represents time. After creating two event types, all the dynamic ego networks are converted to two-dimensional feature vectors. Each feature in that feature vector corresponds to one event type. Each node in the network view corresponds to a dynamic ego network with that node as a focal node. Therefore, each node has its own two-dimensional feature vector. The network view is turned into an MDS plot in which the nodes are positioned based on the evolution patterns of the corresponding dynamic ego networks. Or in other words, the network view turns into a spatial layout of dynamic ego networks. When I hover over a node in the network view, the evolution pattern of the corresponding ego network is shown as a pixel display. As the nodes may overlap, I can jitter them by clicking this button. You can see that as I move along this V shape, the number of orange pixels in the pixel display increases. This means that the ego networks towards the end of this V shape maintain a smaller size over time. John Lavorato is an obvious outlier because he maintains a very large size over time. You can see that there are a lot of blue pixels in his pixel display. Many other ego networks maintain a very small size over time, as you can see from their large number of orange pixels.